on qualitatively predicting reaction entropy. So entropy, randomness, or chaos. So this is actually pretty easy to make a concept of in your head, because what would cause something to be more all over the place? If you can have molecules kind of in the same place, they'll have a low entropy. If they're everywhere, if they're all random, if they're moving around at high speeds or something like that, it's going to be higher entropy. So you're basically asking yourself, what would cause that? So there's a few things that could cause it. If you can increase a temperature, if you can increase the temperature without changing anything else. So for instance, if the volume stays the same but the temperature goes up, then you have more entropy because the molecules will be moving faster and they're more randomly distributed. Okay, so that's one. Also, if you have a phase change towards gases, since they're moving faster and moving everywhere, if you produce a gas as a product, you'll most likely, if it was, say, liquids or solids in the reactants and a gas in the products, you'll have a higher entropy. Conversely, if you go from a gas to a solid or from a gas to a liquid, you've reduced the entropy. Okay, you've reduced the randomness. So all of these can kind of go either way. If you make a mixture out of pure substances, all right, so where the substances are not all in the same place, like in a sugar cube, it's a mixture of sugar and water, for instance, where the sugar is going everywhere. That's more random. So if you make a mixture, you're going to have a higher entropy. If you somehow separate that mixture, say evaporate the water and put all the sugar back into sugar crystals, then you're going to lower the entropy. And the other one that I think is really easy is kind of like that. If you produce more volume but keep the temperature the same, it's more random. So if you had all gases and the reactants have a low number of moles of gases, but the products have a higher number, then the entropy goes up because you're spreading it out over a larger area. And backwards, if you have a higher number of moles on the reactants and a lower number of moles on the products, then your entropy will drop. All right? So I hope that helps. That kind of gives you just a place to start. Let's look at these examples. In the first example, I have all gases. And since I have all gases, I'm going to check the number of moles. So on the left, I have 2 plus 3 is 5. On the right, I have 2 plus 4 is 6. And since I have that means my entropy of reaction is positive. It actually has gone up because I have more moles of gas at the end. In the second one, these are all gases. Okay, that's good. Maybe it's the same kind of problem. I've got 1 mole of gas and 2, so I have 3 moles on the left, I have 1 mole on the right. Well, that means it's going to go down, right? If you have a lower number of moles on the product side, your entropy of reaction has dropped. So let's look at the last one. They're not all gas, so I can't do the same kind of problem here. I've got solids and liquids on the left. I have solids and gases on the right. Well, producing a gas is going to have higher entropy than keeping it solid or liquid, because a gas is more more everywhere. So since I've produced a gas, I can say that my entropy of reaction must have gone up. Okay, so I hope this helps you. I hope you're doing well, and just keep coming back.